Okay, so now we're going to move on to deduplication on either the local or remote Actifio appliance. I have grouped these together because logically they are the same thing. You are moving data from one pool to another with a request to deduplicate in between. The one defining difference being remote dedup involves some network sessions. But as far as taking data from one pool, placing it into another pool with the intent of deduplicating it, using matches from that pool to shrink its footprint is the same, whether it's local or remote. Again, the only difference is that the remote pool could be one rack over. It could be the other side of the data center. It could be the other side of the world. The network medium in between them really doesn't matter because, again, all we're doing is taking data from one pool, putting it into another pool with the intent of deduplicating it against the other data sets present in the destination pool. All right, so for good keywords to search in our dedup log. Now, these are going to be critical. Our dedup log is full of hashes and things that are not meant to be read by humans. So it's really vital that we utilize this keyword list to really bring us to the most important portions of the logs. So we're going to have job number. Job number is always going to be a good go-to. If you're ever not sure what to look for your job number. We're going to look for progress. This will display similar to how we saw in the UDS agent log or UDPPM, where we will have a log line, and then we will finish that log line with how much progress we have made through the job. We can also search for panic. Now, if we search for panic and we get a hit, a support case needs to be opened immediately. Panics can be caused by, there's that pesky janitor again. Not only did they pull your network cable out with their mop handle, but in an effort to fix it, they kicked their mop bucket over and they flooded your disk array. This would cause a dedup engine panic if its pool hosting data went down in a hard fashion. You will see the engine panic. We do actually want to panic in this case. It is similar to what you found in a kernel panic, but our dedup panic is actually a much more controlled panic. We will immediately stop touching your dedup data. We will remove all information from cache. We'll get it written to the disk. We'll do a quick verification of our indices and our hashes, and then we stop. We will not read or write any more data until one of the Actifio dedup engineers actually gets hands-on with this system, corrects whatever problem this is, to verify that you can then bring the deduplication engine back online and move forward safely with all of your data intact, able to be recovered, restored, or served whenever you'd like it. We're also going to look for disabled, error, fail, and certificate. Now, certificate is a unique search term for dedup. Now, I did mention at the beginning that the ADHD log, which covers deduplication and remote deduplication, also handles all secure communication, and all communication between CDSs is secure. All of that logging also goes in here. So when we're establishing these trust relationships with these other appliances, be they other CDSs, storage cabinets, data stores, nearline cloud repositories, one of the more common things that will cause a connectivity issue is a failed cert exchange. And we'll be able to identify that very easily by looking for the certificate keyword here. Now, I did spend a couple extra minutes on the keywords. This is I cannot stress this enough. The dedup log is incredibly verbose. The job that I'm using for this example here today was 3.2 gigabytes of incremental data. It spans 21,000 log lines and is noted in 4,539 of those lines. That is not reasonable to expect anybody to read through and pull out the pertinent information. So we've really got to be clever with our search here to really pinpoint what's relevant to us. So we're going to continue on. We're going to use the successful snapshot that we saw in slide 23. We're going to continue to follow this same image, which, remember, started off on a SQL host. Now we've snapped it. We've got it on a staging disk. We've removed that staging disk from the host. We've put it away. And now we're starting to get into the dedup applications. All right, so we're going to start off with a healthy example of what a start of a dedup job looks like. Now, I did snip out a bit of it. Like I said, it is very, very verbose. This section here could be anywhere between 50 and 100 lines, depending on how many other appliances we're talking to. If you've got 5, 10, 30, 50 certificates that have all been exchanged, you'll actually see all of the exchanges get enumerated in this. That's just us verifying that we can see all of our, what we'll call cluster mates, our other 5 or 10 or 50 CDS or Sky appliances that we want to be able to talk to. And it will all be enumerated here. Now, we're going to search for the job number, and all of the information that is basically a pre-qualification of the job sits in between these dotted hashes you see here at the beginning and at the end. A couple interesting things to note. If you look at the bottom line of the top portion of the snippet, you'll see sent 26675, et cetera, bytes of control data. So what we do, if we think we've seen this data before, is we will take a piece of data from what we think is the existing data set. And then we will then take it out, we'll match it up against that image that just came in to be deduplicated. And if we make all good matches, that's what our control data is. We want to make sure that the dedupe data that we looked at in the back end actually does correspond to the data hosted on the image that we've just been asked to deduplicate. So when you see that control byte data, that's what that is. That's verification that we've made some good matches and we're getting ready to progress down the right road. Another interesting bit, and this is just before it ends, is we have actual data rate, which is interesting. So it'll tell you how much throughput in bits we're getting on the deduplication process. And if you see logs that resemble this, that's great. You've got a great start to a dedupe job. And at this point, once you see that bottom hashed line go by when you're doing your log search, now we actually haven't deduped yet. Everything we've done up to this point is pre-checks, validation, and then we start the actual deduplication. And again, we're going to continue to look for the job number. Now we have a new job number because it's a dedupe job, not a snapshot job. And this is normal messaging. You can see the ADHD 2-cop merge, sequence, num, diff offset. Now that offset is actually sector offset. That has to do with actually sector drift and data drift. Honestly, nothing you need to worry about, but I do want to point it out and just kind of explain what some of this stuff is so you have an idea of what you're looking at when you get in there. The important part is with the job number, we can also find progress. So if we have a dedupe job, a remote dedupe job that we feel like, maybe is running a little bit long, we can actually look in and see the real-time progress. As we know, sometimes the UI doesn't update as frequently as we'd like, especially when we're really waiting on that data and we're kind of camping out on it. The whole watch kettle never boils kind of scenario. So we can actually just look at progress. We can see what's going on. And also if we do run into some sort of an issue, we can use progress to identify at what portion of the job we encounter the issue. A couple more details on that in a moment. Now is when we will start.
Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.